Yeah, there we go. Well, welcome everybody. Hey, welcome to Astronomy Daily Live for I think this is the 8th of May, 2019. Is that right? I think so. It's 2 hours UTC. So yeah, I think we're good there. Hope everybody's doing well out there in the universe and the world. Yeah, everything's good here. The sun is just setting here in southern Arizona, and it's a pretty nice sunset. Not too bad out there. Still got some clouds, so you know, I've got I've actually got quite a bit of data right now, so I'm not too worried about cloudy nights at the moment. I've got way too much data. So yeah, I hope everybody's doing well. I'm gonna look at the chat and see what's going on there. Carolina Sky Astronomy, hey, nice to see you. Chuck, nice to see you there. And on the panel, hey, Bobby, what's happening?
Nothing much. Just living a good day.
That's nice.
Yeah.
Nice. So I can hear that a little bit in the background,
All right, I'll turn that down a little bit.
just a wee bit, please. Don't fall over or anything or crash
I know.
and burn. So yeah, this is just a daily, fun, casual get-together of friends from around the world, and we sit and we talk about astronomical things and spacey things and sciencey things and who knows what else for about an hour or so, um, more or less every single day. It's not a sure thing, but I think you know what in the I've been doing this over a year now, at least. I think we've only missed a few, so that's not bad. That's sort of an indication of the activity in my life, or that is the non-activity. So that's mostly done on purpose, just because I think it's always just great to sit here or work outside or do what I'm going to do and not have to worry about too much, at least. So yeah, it makes it super easy and it is super fun to come here practically every day, 2 hours UTC, and think and talk some kind of astronomical topic of some sort. So yeah, hope everybody's doing well. So it's been it's been dark at Jim's location for a couple hours now. Carolina Sky Astronomy, you just posted some pretty good shots of Jupiter. Looked really great. Um, yeah, and it's not incredibly rare, to catch a shadow, but it is rare enough, and it's extremely cool, to see those kinds of things. So so nice, yeah. So he was able to capture not only a shadow of one of the moons transiting Jupiter, but he could also pick out three other moons. So very awesome. Yeah, extremely cool. And yeah, so check out Carolina Sky Astronomy over on YouTube. He posts there, I don't know, few times a month, something like that. Um, so yeah, and of course, the best thing is the world for the entire world is to, actually see that kind of thing with your own eyes. So, you know, having a recording of it and being able to process it um, later um, is always awesome, but it's always best. There's just something a little extra about seeing the real deal thing. And, it definitely isn't going to look exactly like what it looks like, even in the video. Um, But Jupiter is bright, and Jupiter's apparent size right now is slowly getting larger and larger and larger as we near the opposition, which is I don't remember when exactly that's happening this year. It's going to be a few more months. Well, no, Jupiter's rising now about 10:30, which is about 2 hours after, and I'm talking local time here, 10:30 local time. That's about 2 hours after. Well, no, that's about 3 hours after sunset. So 3 hours after sunset,
so there's Tom, Orange and I think Page Master joined, and Indy joined in.
Yeah, hey everybody, welcome. So I'm just thinking out loud a calculation to figure out approximately when Jupiter's going to be at the opposition, which is on the opposite side of the sky as the sun. So as the sun sets, Jupiter is going to rise. Well, right now that's happening about 3 hours after sunset. But because of the motion of the Earth around the sun, every month, I think I've got this right, every single month, the right ascension of a particular target moves east.
Okay.
So
2 days from now, according to HA, I don't know what that is. Or May the 9th is Jupiter's next opposition. So what's HA is?
Well, so when is opposition? When does it say opposition is?
May 9th.
Oh, 2 days from now? No. Absolutely not. We've got another month. I think you're a year behind her, Arnstro.
Yeah, heavens above.
Heavens above, of course.
Yeah.
No, I think it's in June. I think it's sometime in June. So yeah, we have another month and a week, something like that, which is right.
Yeah.
Which is right. So what that means, of course, is that Jupiter is going to rise as the sun sets. And so every single day now, Jupiter will rise a little bit earlier and earlier and earlier in the day, or in the night. So we will be able to see it at a more convenient time. We won't have to get up at 4 o'clock in the morning anymore.
Eventually the correct saying of it is June 10th of this year, right?
June 10th of this year sounds about right. Yep. Arnstro, nothing gets by us here. Nothing at all. So yeah, you can make all the mistakes because we will catch every single little thing. Absolutely. So all right, well, cool. So I've got the hydrogen hydroxide here, HOH. So cheers.
And I got some plenty of bottled water. So cheers.
Nice. And the opposition is also approximately when the Earth and Jupiter are closest, which means its apparent size is at its largest. Yeah, thanks, Arnstro. Yeah. I'm absolutely no good at tests. So the fact that I've passed, That's pretty astonishing. So I usually run away from tests.
You can't run away forever, baby.
Right. Okay. So I think you know Page Master yesterday mentioned
Oh yeah.
the the Spitzer telescope, and this is an infrared telescope. I think
So
in
according to Page Master's link, um, it'll be well placed for opposition to consideration of Ophiuchus. It'll be visible for much.
Ophiuchus. Yeah.
Okay, thank you. It'll be visible for much of the night, reaching its highest point in the sky around midnight local time.
Yeah.
So I'm
Yuppers.
just reading the first paragraph, if you don't mind.
Yeah. Yep. I see
Unless
that.
you want me to go on ahead and read and keep on reading, I'll just do the first paragraph and that's it.
All right. That sounds good. Yeah. Yeah. I think. Yeah. It's it's getting more and more convenient to both see and observe Jupiter. So yay, yay! It's a great planet, of course. You can see at least four of the moons. I don't know. The rest of the moons are really, really, really small. Um, kind of hard to
Now,
see.
I have a question today for all of those radio freaks. Can we still listen to Jupiter today?
Mm-hmm. Oh yeah, absolutely, absolutely. The
I
explanation that
I wonder if like anybody has like a found a decent video of what the sounds of Jupiter is going to be like. That's what I want to know.
well, you can make those sounds anything you want as long as you have the data. You just need to translate it into sound, and that's super super easy to do. But that's sort of up to you to decide. What kind of data or what data values are going to represent certain sounds. So so, but yeah, I mean, otherwise it's pretty easy to do that. Relatively easy.
Yeah.
So that's ERT radio in the background there.
Yes.
For some reason, it's getting louder and louder and louder. I think you have a plan.
So I lowered it down a little bit more.
Okay. I
I
think that you just have a plan. I think it's a conspiracy of some sort.
I blame Amanda Curran if that's true.
Yeah, and of course,
Because that's her on the radio right now. It's that Foxy Radio Pirate Show.
yeah, cool. So, so Jim, you're exactly right. With Jim's videos, he also creates the music in the background, and it's some good stuff. It's the kind of stuff that I like, and it's the kind of stuff that I like to make up as well. So yeah, awesome. It's great that we have similar tastes. So, PageMaster yesterday was talking about Spitzer, and he actually posted a link to sort of a data access portal, and I couldn't I I couldn't wait until the live stream. This was just way too much fun. So I've actually looked into it already a little bit and grabbed some data. But I will show you what I did. Excuse me. Let me. It's absolutely incredible that we have access to this kind of data now. I mean, you could very, very, very easily make a career out of just working with the data
Now
that,
I have a question. Is
yeah,
Nightbot down for some reason?
not that I know of.
Because I just typed in a command and it's not responding yet.
In the chat,
Yeah. Oh, I
they
just
work.
refreshed it. I just refreshed it.
They
I had to
work.
run a malfunction check.
Uh-huh. No, Nightbot is responding. Yay. Yay. So, but yeah, I mean, one could make a career out of just working with the data that is currently available, and that's absolutely nothing compared to what it's going to be like in 5 or 10 years. It's going to be insane. You don't. I mean, and why, right? Why would I, in my right mind, use use this thing if I can get HST quality data? It's a no-brainer. So yeah, that's sort of where we're going. We're not quite there yet, but wow, there's a lot of data out there, a lot.
Now, the
Um,
Earth radio command, can that be edited to actually include the Mixer link as well?
um, yeah, I don't know.
If
We
you
can
can,
play with that.
yeah.
Yeah, I'll see what I can do about that. Cool. All right. Well, so anyway, what I did is I went over to the link that PageMaster had posted, and I'm gonna share my screen, and I'm gonna go over here to there, and this actually isn't exactly the link he sent me. Oh man, I don't know what it is now. It might just be this first. Oh
Yeah,
no.
check the chat.
Okay. Let me look at the chat
Yeah.
again.
And you might want to
Um,
scroll up to.
oh,
Oh, it's on the top.
I don't see anything new here.
Scroll up. There it is. The
What?
one that says, yeah, the one that says in the sky.
Oh no, that's not the one I was talking about. I was talking about the one he posted yesterday.
Yeah, I think Page Master, if you can repost it again, please, that would be great.
Yeah, go for it. Anyway, so I just typed in our most recent object of the day here in GC 6397, and I gave it a radius to search for things around there. I'm not quite sure what level 2 is, but I think I think that's probably the sort of the reduced data, the calibrated data. Can't be sure about that, but that's usually how these things go. Is that the higher the level, um, the more work has been done to it. So, and it was sort of the default, so it's like, okay, I sort of trust those kinds of things. Um, Probably easy enough to find out what those are, but there's a whole bunch of other options too, depending on if you want to specify anything with the instruments or with the wavelength range. So I think these are the three instruments on Spitzer. I don't know that much about Spitzer, but as you can see, everything is chosen here. You can uh, set some other parameters here too. The exposure time
Okay.
and the date.
If the chat serves me right, I think you're right there as well.
Let me look and see. Yes, thank you, PageMaster. Yeah. Okay. Yeah, I think I am really, really close. Maybe I am. Yeah. Okay. Anyway, so you know, I just decided to just go with the defaults here, and yeah, you know, but yeah, you know, there's a lot of data available, right? There's various filters here. Um, there are some other wavelength ranges, I guess you call here. I'm not quite sure how that works. And then there's some even longer wavelength here too, all the way up to 160 micron. By the way, you know, I have to rescind and apologize for some information I gave you yesterday that was incorrect. Let's go over to SDO really, really quick. And it was actually looking at PageMaster's post over on the ADL Discord server that I noticed what mistake I had made. I had said that these are in nanometers. That is incorrect. These are actually in angstroms. So that's 193 angstroms, which is 19.3 nanometers. So, you know, they're just a decimal point off. But I was going, yeah, I had that very, very wrong. So you know, erase everything I said about these being nanometers. These are not nanometers. These are angstroms. Angstroms. So they're very, very, very short wavelength. You know, way out in the ultraviolet, way, way out there. So, you know, even if these were nanometers, they would still be in the ultraviolet. That's how far ultraviolet they are. So yeah, I just wanted to correct that. Don't want to give any incorrect information that I should have known better about. So, all right. Okay, well, let's, so what I did at this point, right, is I was just able to type in the name, and it went over to Ned. I think it tries Ned first, and if it's not able to find anything in Ned, then it goes over to Simbad and tries to resolve the name there. But it probably found it over on Ned, and as you can see, it's what this search engine needs is the coordinates in the sky, either in, you know, degrees or in hours and degrees. So either of those work. In this case, it was able to figure all that out, so I didn't have to type in any numbers except just the name. That works for most objects, right? If we were to do like Messier 5, you can see it comes up really, really fast. So so yeah, so that's how I did that, 6397, like that. And I set a radius, as I said. Can turn that off, and then we can do a search. That. And so this is what it finds. Go ahead, Bobby.
All right. So talking about the sun and making that correction, for all your radio freaks out there, your solar flux is at 78, your A index is at 5, and your K is at 1. Your sunspot number is 45, and I think we got 2 sunspots with that other sunspot just finally emerging from the east.
Cool. Very, very cool. Yeah, and they, you know, if there's a sunspot count of 25, then that means that you got, you know, the 2 big ones there, and 23 others that you know, are harder to see or elsewhere. Who knows? Who knows? So yeah, you know, I really, really like this interface. Once I sort of play with it a little bit, it's really, really neat. So, you highlight these things, and over on the right, and you can actually change the width here and stuff. Over on the right is the, sort of a description of the proposal that was written, to get this data.
Okay, before you continue, I was looking at the sunspot regions, and I was looking at the flare possibilities. Region 2740 has the possibility of having a C class flare, which is 50%.
Okay, so there is a little bit of mixing going on, because C-class flares isn't well, no, a C-class flare is actually the lowest class. So there's
Yeah, and
CBA.
they are rating M class on 2740 at 5%. Your C class is at 50%. Your M class is at 5%.
Yeah. So doesn't look like there's going to be a lot of major activity, but yeah, who knows? Who knows? So anyway, yeah, I thought that was really, really neat that they, you highlight this and you sort of see, some basic information about this data set, right? They're showing off.
Yeah. Chuck Dagler wants an M or an X.
Yeah. Yeah. So, just sort of a basic information here. Cool. I don't know what the rest of this is. Oh, that's some kind of image. This is the footprint of the detector themselves. We'll look at that in a little bit more detail. So then I just, I think what I did, oh yeah, I went over here because this is where the actual
Now, I
data
have
was.
a question for you.
Mhm.
For like auroras, is it more better observed when if a CME hits the Earth or an X flare hits the Earth?
Well, um, I think if you have an X flare, you're probably going to have a CME as well. So
Yeah.
while those two things are different,
So,
they
so Art Astro thinks proton flux is more directly related to auroral strength, but yes.
yeah, I think that's exactly right. There's just a lot of stuff, and that is definitely going to cause some kind of aurora. Yeah, absolutely. So here it is. You can sort of see that they've got these four observations at four different wavelengths, like that, and they're all images. Doesn't say when they were taken, but they are different in terms
And
of,
thank you, Page Master. X flare will be accompanied by CME.
yeah. Yeah, I can't imagine that one wouldn't be. um,
Yeah.
so let's see. I don't know what this is showing off here. Okay, it's just showing. Okay, kind of cool. Anyway, so I grabbed these and I put them into DS9. And so this is what I came up with here. We can look at these one at a time. So this is the one taken at 3.6 microns. We can play with the scale here a little bit and mess around. So this is Spitzer data. So this is infrared. So there's some Spitzer data. We can zoom in a little bit. Oh, here, if you zoom out, oops, sorry. you can see the full Spitzer field of view. Isn't that's pretty funky there? And I didn't realize that 6397 was so close to a really bright star, but it is. Wow. Yeah, so there it is at 3.6 microns. You can kind of play with the brightness and contrast here a little bit. Sometimes it helps if you colorize it in some way. Sometimes it helps. Sometimes the color just sort of helps, you know, show things off a little bit. Of course, it's all false color because we're looking at a grayscale. That's all the information we have, but we can add sort of a blue palette to it or a rainbow palette. And sometimes things, you know, that you may not see in gray. See, like there's some really, really faint stars in this area that you can sort of, you know, they start to pop out a little bit, maybe, when you do that. So, yeah. Okay, so there's, as I said, the 3.6. Let's go to the 4.5. That's this one. And I'll zoom out again here so you can sort of see. Notice it's on the other side. So there's 4.5 microns. So here's 3.6. Oh, let's get the same zoom value. Let's do that, and then we'll go over here and go zoom of half. There we go. So now we can go in between these. I'll sort of make them the same background. Yeah, so you can sort of see what's going on there a little bit. Those look almost identical, which is interesting in and of itself. But some of the stars, you know, if you start looking closely at these guys, they do change. There's slight changes there. Okay, so let's go on to 5.8 microns. That's this one. Let's see, we'll have to zoom by half, and I probably have to scale weird here. There's that big bright star over here. Look at how bright that thing is. So my guess is that this might be a lower resolution. They were talking about that in the search parameters. So you can sort of see how much sharper these look. Well, maybe. It's hard to tell. Kind of hard to tell. So that's 5.8 microns, and then they've got an 8 micron, which is this one. We'll sort of zoom that in the same. So again, I'm not quite sure if this is the high res or the low res. It's kind of hard to tell. I've also been trying to think about the possibility that here, let me zoom in on this one because that's pretty obvious. So here's sort of the star blob. You see this ring around it? Trying to think about the possibility that that might be an airy ring, which is just an optical effect. at 8 microns, you may see things like that, because the wavelength is getting so long, that yeah, the atmospheric distortion may not be isn't as much at 8 microns. So these low level effects, like an airy pattern, you might that might be what we're seeing there. I'm not quite sure. If you look at like some of these fainter stars, see there's a definite ring around that. See there? So I'm thinking that those are airy rings, which I think you would sort of expect to see at this wavelength. So I think those are. I don't think that those are like diffraction patterns of any sort, although they might be. Yeah, I might be completely imagining that, but I don't know if anybody in the chat has a thought or a comment about that. Yeah, I've never seen anything like that. Yeah. Well, and I think where you are, Carolina Sky Astronomy, I don't think you're going to see it anyway. So, but anyway, so yeah, it's so yeah, we're able to grab Spitzer data here. This is just for that object, but I kind of thought maybe we should see if there is something else. Maybe maybe up in the north. I just did a thing for Messier 5. Maybe we should look and see there, because that too is a globular cluster.
For some whatever reason, Cosmic, it's on the Hangout feed, but I'm not sure it's also on the YouTube feed as well. But you keep on cutting out and stuff.
Oh yeah.
Yeah.
Well, there's not much I can do about that. It's probably the old potato just running way too many things. So I'm just gonna keep going here, see what happens. So let's just quickly look at Messier 5 here. Oh wow, so quite a bit. Wow. Okay. Let's well, let's take a look at this one. Let's do, well, this one definitely says M5. Let's grab that one and that one. Okay. So we just prepare download, and then it does that. We don't need level 1. It's going to send it to my other email. So you can grab the calibration data if you want, or the raw data. That's very cool. Prepare download. There it goes. So there's this one.
I think what's also good about it is you don't have to look at it. You don't have to check the email. It's already there.
It's already there. Yeah, it's just sort of a record, which is, I guess, a little bit nice. Not entirely necessary, but yeah, okay. Can live with that. Let's see. So let's go here and here.
It's
And
still downloading though.
yeah, that's okay. Make another folder here, I think. Let's call it Mystery 5. Oh. We'll move this guy over here. Move him over to here. We took a look at Messier 5 here. Let's see, how's the best way to do this? Let's just do that. So we'll unzip this. I'm going to look at it first just for fun. Okay, so it's just a bunch of those. So we can just unzip it here. Whammo. Like that. So now we got to go
Look
into...
at all those fits.
It's having a fit. For sure. It's having a fit.
As in fits files, by the way.
As in fits files. Okay, so let's just... I have no idea what this is going to look like, but let's find out here. So we're going to go over here, and go here, there. Oh, you know what? We don't have to do that. That was dumb. Let's go over here. And let's just get rid of all these. Oh, there we go. New frame. Open. I'm going to go... Whoop, went too far. Uh-oh, there it is. 5. Channel 1, PCB. So that's just a little tiny...
You can't select them all on DS9 or no?
I don't think so.
You could have tried.
Yeah, I could have. Yeah. All right, well, that's not incredibly interesting.
To Amore.
Oh, that looks like the same, almost exactly the same thing. Huh. All right, well, I'm not getting too much satisfaction with that. 46. Oh, there we go. Okay, so there's M5 with Spitzer. That's pretty cool. Oh. Oh. Do that, and then we can do... Oh, we're already log. Okay. So that's pretty nice. Don't know... I have to go back here. Oh. And find out what wavelength. I'm not seeing any wavelengths. Yeah, I'm not seeing much. Oh, okay. I see. Wow. So this is, yeah, this is the individual level 2 data. All right. Well, cool. Anyway, so yeah, I just think it's absolutely fabulous that we have access to this stuff now. I think it's great. And it's pretty easy to, you know, grab what you want. It's got all the sort of the useful info here. Yeah, some kind of pointing thing there, kind of hard to tell. So yeah, this object has been observed quite a bit, it looks like. Doesn't give a, yeah, it doesn't give a any kind of a date range there, but is it here? Yeah, it sort of does here. So these are observation requests, and this is the actual data. Oh, okay, I got you. So we'd have to look and see if the RA and DEC actually match, but we're talking about images here and all of that. So okay, cool, very neat. Yeah, we'll have to look into this a little bit more, I think, as time goes by. Very cool. So yeah, it's absolutely amazing to have all of this available to us. Just super, super easy. Cool. All right. Well, I'm going to take a big gulp of this fantastic fluid here.
No crisis, please.
No crisis? Oh, come on. We need to have a crisis once in a while, don't we? X-flare. YouTube feed is good, at least according to Carolina Sky Astronomy. So,
while it's at no crisis, I said you ran out of your drink.
Oh, no crisis. Yes, not quite yet. Not quite yet. But you know what? I think that I'm gonna do. I'm gonna go a little bit short on today's live stream. I'm noticing that we've still got about 10 or 12 minutes in the hour. But yeah, you know what? I think that this is a good or pretty decent stopping point. So maybe I'll just end this a little bit early. You know, we usually go way over anyway. So you know, maybe I'm trying to balance the force a little bit here. Who knows? Who knows? But yeah, I think unless anybody has anything else, I think I'm going to call it for today. We'll just call it a Spitzer day, and works for me. Yeah, I've never looked at any Spitzer data before. We'll have to find out a little bit more about this spacecraft. It's been around for a long time, but I don't know how large of a telescope it is. I don't know where it is. I don't know exactly what its mission is. I do know that it's infrared, right? Which is extremely important. I mean, the entire electromagnetic spectrum is important. So being able to observe objects at those wavelengths without any kind of distortion, and you know, have to correct something I was saying before about seeing the airy pattern in those things. There isn't going to be any atmosphere to distort at all. So yeah, that convinces me even more that those might be the airy pattern there. It's a very decent possibility. So yeah, I want to find out a little bit about that. Because yeah, I just want to find out a little bit more about Spitzer.
Okay, so Bagemaster just gave you something called a press kit.
Okay, cool. Yeah, that's a good start. Of course, these days search engines like Google and others are best friends. So so yeah, it'll be extremely easy to find the kind of information I like. I like to see all the details, all the technical details too. So yeah, let's I'll sort of dig all that up and or find it, and let's look at Spitzer a little more carefully tomorrow. So okay, well for now I think I'm going to get on out of here. I think I've got a friend who wants
And
to
before you
also exit.
go, Page Master also released a fact sheet.
Excellent. Thank you, kind sir. If you don't mind, Page Master, put those over on the Discord too. This chat doesn't vanish, but it may not be as accessible as Discord. So if you don't mind, push it over there as well. He's extremely interested in my photograph of the 8.4 meter mirror there. So I don't know exactly what he is looking at. Maybe he sees me. Who knows? All right, everybody. I'm going to get out of here. I will see you in a little, just maybe about 23-ish or so hours, something like that. A little less than one of these little spins. All right, everybody. Take care. Peace, cheers, and all that. Live long and prosper.
Live long and prosper.
And I will see you later. Bye.